Welcome back. In this clip, you would practice with me magnetic field and electromagnetic induction. Let's dive straight into it. A magnet is moved through a core of wire. The EMF produced in the wire depends on first the number of turns. It depends on the number of turns, the speed at which the magnet is moved, and also the strength of the magnet. Option D, all of the above. Number 2, on an AC generator, which of the following does not apply? One of the following here does not apply to AC generator. That is commutators, right? Split ring, split ring, and commutators do not apply to AC generator. They only applies to DC generator. While spleen ring, see I'm here, this spleen ring applies to AC generators. 3. The electrical supply from Kenjida is transmitted at high voltage and low current. Keep that in mind. That's what they call high tension. Of the order hundreds of kilowatts, but it is converted to domestic use of about 200 watts by option E, a transformer. Number 4, which of the following statement is incorrect? Which of the following statement is incorrect? The sensitivity of a galvanometer, which incorporates an optical lever arrangement, may be increased by providing. Which of the following? The correct answer actually, when you provide a larger torsional control. So here they say a larger number of tones. No, when you provide a lesser number of tones. So A is incorrect. A thinner suspension with a smaller torsional. When you provide a larger torsional control. B is incorrect. Also C, a special alloy. Incorrect. Number 4, option D, all of the above, they are incorrect. The opposite is actually what you would need. So I want you to turn the opposite and create a note out of it. So you will now put let's say a larger number of tones in the core. No, a smaller number of tones. Small torsional control, actually large torsional control. Which of the following statement is correct? The magnetized state of an iron bar can be destroyed completely by option A. When you hit it, you destroy the magnet completely. When you use a Fleming's left hand rule, the wire moves into. The figure shows a current I flowing in a copper wire situated in a magnetic field existing between the pole piece of a horseshoe magnet. Which of the following statement is correct? The wire will experience a force in the direction into the paper. The wire experiences a force in the direction into the paper. 7. On which of the following is the operation of a moving core galvanometer based? Moving core galvanometer is based on force on a current carrying conductor in a magnetic field. Option D. 8. A magnet is similar to a bipolar charge system in that it consists of two opposite poles, north and south. A is correct. The Earth magnetic field has a south pole near the geographic north pole and a north pole near the geographic south pole. B is correct. C. The force of attraction and repulsion between the opposite. The force of attraction and repulsion between opposite and between like poles obeys a law. Opposite and between like poles obey a law that is identical to the law of Coulomb's law. Number 8 is option E. Option A and option C are correct. Option A and option C are correct. You could take a look at it again, rewind. Number 9. The name given to the characteristic behavior of a substance which set their length perpendicular to a strong magnetic field instead of in line with it, they are called paramagnetism. Right, paramagnetism is a form of magnetism in which certain materials are attracted by an external magnetic field and they form internal induced magnetic field in the direction of the applied external magnetic field. Open bracket, paramagnet does not retain its induced magnetism. It loses it after the external magnetism has been removed. The paramagnet na materials wey be say if you bring an induced magnetic this thing to them, they go feel they act as if they be magnet. But if you take them away, they will lose that magnetism. They get. You understand? Just like a small child, you follow them to school. There's this confidence they have. But any day you know that same teacher, they see the teacher, they go hide o. Or it's like that to follow your young one go fight or go threaten somebody. But they know where your young one, where you know they there. You understand? In the diagram below, a straight vertical wire is placed between two opposite magnetic poles which are separated horizontally by a short distance. If a current is passed down the wire, in which direction will the wire move? In which direction will the wire move? First things first, you need to understand Fleming's left hand rule. The forefinger, that forefinger, it shows direction of the field. The second finger shows direction of the current, while the thumb shows direction of the motion. So number 10 is option A, towards the observer. 11. The best material for the core of the primary and secondary coil of an induction coil is. Best material for the core of the primary and secondary coil of an induction coil is. The best materials to use is soft iron, because it becomes magnetized easily but also loses its magnetism easily. But easily loses its magnet to soft iron. 12. Which of the following statements are real magnetic materials? Iron, steel, nickel, and cobalt are right. Real magnetic materials: iron, steel, nickel, cobalt. Iron, steel, nickel, cobalt. Iron, steel, nickel, cobalt. Right. These are called ferromagnets. They are called ferromagnets. Continue. A ferromagnet retains its magnetism after an external magnet is removed. Give space and write. A diamagnet is not attracted by a magnet, or it might even be slightly repelled by it. It's not attracted by a magnet. So diamagnet no get business. Dia is DIA. It doesn't have business with this thing. It's not repelled. It's not attracted by a magnet. Ferromagnet are those items that are highly magnetic, while paramagnet are those items they become kind of magnetic when you bring another external factor of magnetism to them. When you take it away, they also loses it. You get the three: paramagnetism, ferromagnetism, and diamagnetism. Which of the following is not directly associated with a direct current? Transformer is not associated to it. 13 and A. 15. A closed wire. A closed core of wire is placed near a magnet. The magnet lies along the axis of the core. Under which of the following condition would there be no current in the core? Under which of the following condition would there be no current in the core? When both the core and the magnet are held stationary. When they are held stationary. Right. The core and the magnet must be in relative motion to one another. Number one. Number Roman figure I. Stationary core, moving magnet. Next. Number two. Moving coil, stationary magnet. Moving coil, stationary magnet. Notice something: one would always be moving faster than the other. If you're not getting it at all, yeah, and so this chapter they be. But I need you to do something. You could go back to your textbook and run through it. In fact, I'm going to insist that you run through your textbook first, your physics textbook, or this topic on your physics textbook before you come back to practice these questions. Next, the induced current can be increased by increasing the speed of relative motion, increasing the strength of the magnet, and lastly, you are adjusting this I'm saying from you. Lastly, increasing the number of turns in the coil. Next, changing the direction of relative motion only changes the direction of current, but the current always flows in such a manner as to oppose the motion inducing the current in the first place. 16. A magnetic needle is suspended first at the Earth's north magnetic pole and then at the point on the magnetic equator. The respective angle between the needle and the horizontals are 0 and 90. Wait, it's supposed to be 0 and 90 degrees. Right. The angle of dip at the Earth north magnetic pole is 90 degrees, but 0 at the equator. So when they say the magnetic pole suspended at the north is 90 degrees, the equator is 0 degree. 90 and 0. It's not even here, but just keep it in mind. Equator 0 degree, magnetic pole 90 degree. 17. Each of the following diagram in the figure represent two current carrying conductors situated close to each other. In which two diagrams are the factors between the two wires attractive? In which of them is it attractive? This one. You know, like charge and opposite charge. plus and minus, this one and this one. 18 in the figure above. 18 in the figure above. QR is a vertical conductor, and the current flows I and the current flow from R to Q. Full stop. P is a point on the horizontal plane, and it's to the south of the wire. The direction of the magnetic field at P due to the current is direction of the magnetic field at P due to the current is east, is to the east, is to the east. 19. The electromotive force obtained from a simple dynamo may be increased by the electromotive force obtained from a simple dynamo may be increased by it will be increased by increasing the speed of rotation, option C. 20. 20. 20. A short bar magnet is placed in the earth magnetic field as shown in the figure. Which of the points I and III are possible position of the neutral point? The possible position of the neutral point, number 20. The possible position that you have I is around II only, option B. 21. In the when see in this middle now be the neutral point. You know if it dey up, you know if it dey down. You get 21. In the figure below, represent an insulated cylindrical core or copper wire round a paper tube. The ends of the core are connected to a sensitive galvanometer. When a magnet was plunged into the core, it was observed that let's go. So the galvanometer needle gave a deflection. Which of the following correctly described this experiment? Okay, we're done with that, right? This question 21. A galvanometer needle gave a deflection. Which of the following correctly describes the experiment? The effect illustrated in the induced electromotive force. This one is showing you the effect that will be illustrated when there's an induced electromotive force. Induced electromotive force, option A. 22. Which of the following methods cannot be used to produce a steel magnet? Hammering cannot be used to. Sorry, heating of the specimen cannot be used to. Heating of it. But see, they say hammering of the specimen in the Earth's magnetic field. But it's supposed to be hammering of the specimen in the east-west direction. Do you get? So we'll go with heating. Heating cannot be used. 23. On which of the following does the operation of a moving core ammeter depend? Moving core ammeter, force on the current carrying conductor in a magnetic field, and also magnetic effect of an electric current. 23 is option D. It depends on those two. 24. Which of the following statement is not correct? Which of the following statement is not correct? Say a galvanometer can be converted to an ammeter with a different range by connecting a high resistance in series. 24. That is not. You can go back to chapter 26. We talked about galvanometer and milliammeter there. Galvanometer, milliammeter, voltmeter. So, which of the following statements is not correct? A galvanometer can be converted now. A transformer, little bit of calculation here. 26. Which of the following is which of the following, if not, is not a part of a DC? It's not a part of a DC. Which of the following is not a part of a DC? It's not part of a DC. Spleen transformer, option D. This question has been repeated before. 27. Which of the following is true of magnetism? Which of the following is true of magnetism? Ion filing cling mainly around the end of a bar magnet, option A. Yes, they cling around the edge of the bar magnet, like the North Pole or the South Pole. 28. The angle between the magnetic meridian and the geographic meridian at its locality on the Earth is this one is what they call variation, right? Angle of variation. Let's see if it's there. Angle of variation. I want us to jot down this point, please. Right, magnetic meridian. Magnetic meridian. Magnetic meridian is a plane through the magnetic axis, while geographic meridian is a plane through the earth geographic north-south axis at a given place. Next line, right. The angle of dip, DIP, also called the angle of inclination, is the angle between the direction of the Earth's resultant magnetic field and its horizontal. And lastly, the angle of dip is measured by a dip angle. The angle of dip is measured by a dip angle. So here now they say the angle between the magnetic meridian and the geographic meridian at a locality on the Earth is called, this is called the angle of declination, right? The angle of declination is the angle between the magnetic meridian and the geographic meridian. This is also called the angle of variation. The diagram below depicts the current induced in a coil as a result of the relative motion between it and a bar. It and a bar magnet. Which of the following diagrams illustrate the direction of the induced current? Which of them illustrate the direction? Option A, look at it, north south, south north. So flows like this. The diagrams too are not the best. The diagrams still are not the best, but the arrow would indicate the direction of motion. Okay, the arrows would indicate it. The north polarity north polarity. Then you have a north polarity and you also have a south polarity. So see, this side south, this side north. See, it flows from north to south. See, north to south, south to north. You see your arrow there. 30. If the inclination at Ibadan is 7 degrees to the south, this means that the Earth's resultant magnetic intensity at Ibadan makes angle 7 degrees with the horizontal direction. Option, they said if the inclination, option B, if they say Ibadan is 7 degrees to the south, the way they interpret them, you go say the Earth, I will need you to go back and read this chapter a bit by yourself. The Earth's resultant magnetic intensity at Ibadan makes angle 7 degrees with the horizontal direction. Number 31. If the angle of declination at a place, there will be a bit of calculation. Angle of declination at a place is 10 degrees. Is calculate the true geographic bearing of the compass. If the compass reads 40 degrees, we're just going to, if the compass reads 40 degrees, we'll add them together. We'll arrive at around 50 degrees northeast. Option A. The tube bearing will be 50 degrees northeast. When a transformer has more secondary windings than the primary windings, it has a smaller secondary current. It will have a smaller secondary current. Option A. 33. The direction of the magnetic field at a point in the vicinity of the bar magnet is always, the direction of the magnetic field is always But before we continue, let's talk a little. I want to give short note about transformers. Right. The higher the number of turns, turns, the higher the EMF, but the smaller the current with respect to, but the smaller the current. Next, I also want you to write down, power is generated, when power is generated, it is high current and low voltage, but when it is transmitted, it is high voltage and low current. Next, before power is distributed to homes, it must be stepped down to low voltage, okay, and high current, or reasonable current, not overly high current. Next, take this down. When home appliances get spoiled due to will get spoiled, this is actually, or maybe get burnt. Say the light burn our this thing. This is due to high voltage and not high current. This is due to high voltage and not high current. It is due to high voltage and not high current. It is due to high voltage and not high current. Next one, 33, right? The direction of, so we say has a smaller secondary current. 32 we say is option A. 33, the direction of the magnetic field at a point in the vicinity of a bar magnet is always in the direction of the north pole of a compass needle would point. The direction the north pole of the compass needle would point, that's the direction that the magnetic field at a point in the vicinity of a bar magnet is always facing. 34, when two parallel wires carrying current in opposite direction, the force on either wire is away from each other, away from the other wire. 34 is option A. 34 is option A. 34 is option A. 35, the wire X in the figure above is at right angle to the plane of the paper and carries a current into the paper. At which of the point labeled 1 to 4 will the magnetic flux intensity due to its current be in the same direction as that of the horizontal component of the Earth's magnetic field? 35, option, it will be at this point. Option C. There's a rule called the fifth rule. I'm going to demonstrate it for you guys subsequently. We'll discuss that one on the group. That is, which of the following ammeter may be used to measure, but that one is option C. This place. If there's a way you do your fist to describe this. Which of the following ammeter may be used to measure alternating current? Moving iron ammeter is used, and hot wire ammeter. Option B. Which of the following ammeter is used to measure alternating current? AC current. See, the both of them get ammeter. One now moving, the other one now hot. So moving, the way you would, because most times people mistake this one and they ask it a lot. So which of the following ammeter is used to measure alternating current? AC. Just imagine you hit a ball in a fire for so long and you throw the ball and the ball is moving. So a hot item moving. So it becomes moving. It becomes a moving iron hot wire ammeter. So moving iron ammeter or hot wire ammeter. So immediately, just imagine you hit something, you can't hot, you can't move. So hot wire ammeter or moving iron. 37, the principle. So that's 36, option B. The principle of operation of an induction coil is based on 37 is option C, Faraday's law. Because there's something called Faraday's law of electromagnetic induction. 38, a dynamo primarily converts mechanical energy to electrical energy. 38 is option A. 39, when a number of identical small magnets are arranged in a line, the strength of the resultant magnet is 39 is largest when they are arranged end to end. Option A. I'm going to stop at number 40 and I will continue from the next video from 40 to the last. Or let's take it to 45. 90. A bar magnet is most effectively demagnetized by when you heat it. If there's no heating, there you go for another option, hammering. Hitting the magnet, you see it, option D, correct. Next, the figure above shows a conductor PQ carrying a current I in the direction shown. At a particular position near the conductor is a compass needle K. Neglecting the Earth's magnetic field, the compass needle will settle in a fixed direction whether conductor PQ is a magnetic material or not. Option C. But one of the properties of the Earth's magnetic field is that pay attention. One of the properties of the Earth magnetic field is that the Earth magnetic flux is entirely horizontal at a place where the magnetic vertical dip is 0. That's option C. 43. What precautions should a manufacturer take to ensure that energy loss in the transformer is minimized? The core should be made of thin sheet of metal, option B. But for which of the following statement is correct about the Earth magnetic field? The angle of declination is the angle between the magnetic meridian and the geographic meridian. That's it, option B. 45. To convert an alternating current dynamo into a direct current dynamo, to convert from AC to DC, you replace the spring ring with split ring. 45 is option C. Replace the split ring. Split is for AC. Split is for DC, so you replace them. That's option C. 46. If a current carrying a core is mounted on an iron frame, the back EMF induced in the core will cause eddy current. The back EMF causes something called eddy's current. We'll stop here, and in the next chapter we'll continue from chapter 47. If you've gotten to this point, well done. I know this would be like one of the toughest chapter yet to even jot item. But what I would always tell students, copy first. The understanding session will be done on our groups, where we would make explanations to everyone. I'm going to leave the link to the group in the description box of this video. If this is your first time joining us, please, we run session preparing students for entrance exam, JAMB, UTME, another A-level exam. If you want to be part of the class, if you want to enroll, so I'll keep the link in the description box of this video. This video, the main purpose of this one is to acquaint the students, so you know how their questions are said. Now when you go through this question with me, some of them will be say, some of the questions you go see and you go put fear for your chest. I know some of them you go be like, this one they exist. Now the target of this video be this. So this one I go hit you into shape, and you take the drill sessions and the explanatory sessions on the WhatsApp group serious, and also you take your test. And when you come back here to go through these videos again, it will be a joy to you. Thanks for watching, and I'll see you in the next one.